All right, hello everyone. So today we're back to the old iPhone videos. We're gonna do notes on empirical formula. Obviously, as always, I will have both a copy of the blank notes and the filled out notes put up online. And then there's gonna be a worksheet also that you're gonna work on, the empirical formula worksheet number 1, okay? To do this, you'll need your periodic table, okay, and a calculator. All right, so empirical formula. What is an empirical formula? It is the lowest whole number ratio of the atoms of the elements in a compound. All right, so for example, CH2O. You can't divide those numbers of atoms by anything. Now, we'll talk about molecular formula in a day or two here, or tomorrow probably. The molecular formula shows all of the atoms, like all the atoms that a molecule has. So this comes from, so take this for example. That could come from sugar, C6, glucose, H12, O6, I should be specific. So this would be like the molecular, but see how those can be reduced? It can be divided by 6 and turned into this. So this would be the empirical formula, the lowest whole number ratio. Now, sometimes the empirical formula is, like the molecular formula is the empirical formula, like water, H2O. That's already reduced as much as it can be, okay? All right, so what we're gonna be doing today is actually figuring out how to calculate or find the empirical formula given certain information, okay? So the first thing to do here is turn percentages into grams if necessary. If they give you, so for example, find the empirical formula of a compound consisting of 75% carbon and 25% hydrogen. So, zoom over there, okay. If they give that to you, now this is where you've got to be careful because we've got the percent composition problems, which are totally different, all right? This says find the empirical formula. So we're talking about empirical formula here, right? All right, so if they give it to you in percent, all you do is just literally drop the percent and put grams. You don't have to do anything else, all right? If they already give it to you in grams, you don't have to do this step, obviously. Okay, you want the amounts of each element in grams. Right? Once you get the amount of each element in grams, then you're going to turn grams into moles, which is what we've been doing for the past week and a half. Okay, using the molar mass. So we've got 75 grams of carbon, and we're going to turn grams of carbon into moles of carbon. Okay, the conversion here is 1 mole for the molar mass in carbon. Now, it's just carbon, so we're going to look up on our periodic table for the mass. Carbon, you go to 1 decimal, that is just 12.0. The 1 doesn't round it up, so it's 12. So for 12 grams of carbon. Okay, then we do the math. So 75 divided by 12, we get 6.25. Now, we don't want to round this answer at this point for significant figures yet. Okay. We want to leave it out. Now, if it's a really long decimal, you can cut it off, but you want to go to, at least 3, 4, 5 decimal places or so. All right, let's do the next one. 25 grams of hydrogen. We're converting grams of hydrogen to moles of hydrogen. Okay, now we're talking about an element as part of a compound. So this is not alone. It's not like, this is not Hofbrinkel stuff, okay? So it's just hydrogen, single one. So you look up on the periodic table, you find that it's 1 in front of moles. You find that on the periodic table it tells you 1 gram of hydrogen, okay, 1.0. So this just comes out to be 25 moles. Okay. All right. Next step. Divide by the smallest number of moles to find the number of atoms of each type of element. So we've got 6.25 moles of the carbon, right? And we've got 25 moles of the hydrogen. You divide by the smallest number of moles. Divide everything. So smallest number of moles is 6.25. So we divide everything by 6.25. Okay, this comes out to be 1. And 25 divided by 6.25 comes out to be 4. This is the number of atoms of each element. So you've got 1 atom of carbon, you've got 4 atoms of hydrogen. Okay. Next, make sure the answers are whole numbers. If they're not, you multiply, which is not common, or round to get whole numbers. Multiplying is not as common, right? So I'm going to skip all this stuff right now because our numbers are whole numbers. I'll go back to this in a little bit. All right. Number 5, write the empirical formula. So we write, now if you have a metal, the metal usually goes first. If you don't have a metal, then you can just do them in any order. Usually the order that I give them to you is fine. Okay, so we've got carbon, we've got 1 of them. So it's just C. You don't put 1s down as subscripts. And we've got hydrogen, we got 4 atoms of hydrogen. So we put hydrogen, subscript 4. And that's your answer. That's how you do it. Okay, all right. Let's walk through another example to get a little more practice here. So on the second page of our notes, I have another example. Okay. A compound contains, hold on. Right. A compound contains 0.0909 grams of hydrogen and 0.409 grams of carbon. What is its empirical formula? All right, so the first step is turn percent into grams if necessary. On here, it's not necessary. We're already in grams. So we're on the second step. Turn grams into moles. So I go 0.0909 grams of hydrogen. Oh, I'm gonna sneeze, hold on. Oh, maybe not. Okay. 0.0909 grams of hydrogen. Okay, now, what I show you for them in general is the work you need to show. Okay, I'll kind of go through it at the end and make sure, but so you need to go grams to moles for hydrogen. We already know that from looking on the periodic table before is 1 for 1. So you end up with still 0.0909 moles of hydrogen. Okay, and we have 0.409 grams of carbon. Okay, we look up carbon, we get 12 grams of carbon for 1 mole. And we get, let's see. Okay, we get a long decimal. So 0.03, so this is the decimal. So I'm gonna go 0.3408 should be enough, I think. Okay. This is moles of carbon, right? All right, next step. Divide by the smallest number of moles to find the number of atoms. So here, I'm just gonna look at these, I'm gonna divide by the smallest. So my smallest one, now be careful when you're dealing with decimals, make sure you're looking in the right spot. Okay, and make sure you're comparing the same, making sure you're finding really the smallest number. So our smallest number here is moles of carbon. So I'm going to divide everything by that. 0.03408. Okay, I get here is just going to be a 1. So 0.0909 divided by the 0.008 gives me this, okay? 2.667. All right, now here's where this comes into play. If they are not whole numbers, then we either need to multiply or round to get whole numbers. So if the decimal portion is within a tenth, then you round. Here's how that works. So if you imagine a number line, okay, I'm not going to do all the numbers, but if you imagine a number line and we've got, you're never going to have anything under 1 because dividing by the smallest is always going to give you 1. So if you got, let's see, so 1, 1.1, 2, 2.1, 2.9, 3, okay, you get the idea. So, and you just keep going. But, so here's how this works. If the number is, within a tenth of the whole number, so if the decimal portion is greater than 0.9 or less than 0.1, so like if it was between 1 and 1.1, so if it was in there, if it was between 1.9 and 2.1, if it was in here, you would round to 2. If it was between 2.9 and 3.1, you would round to 3. Okay, if it's between 3.9 and 4.1, you round to 4. Okay, now this is just generic round, like, this rule is just to make it a little easier to decide if you're going to round or not, okay? So you would round. Now, if the number is not within a tenth, so if the decimal portion of the number is between 0.11 to 0.89, so if it's in here, so I'm just going to color in these circles so you can match up the colors. So if it's in this area, it's too far to round. You can't round those numbers. All right, and I'll show you what you do if it's not. So if it's within a tenth, you round to the nearest whole number. If it's not, then you have to do this multiplying. Okay, here's how the multiplying works. So if we look at our example, in our example, we've got 2.667. That is not within a tenth of a whole number. So we can't just round it. So here's what we do. We figure out a number to multiply this by that will get this to a whole number. Now, usually you can just guess and check numbers. There is a little better way to do it, but most of the numbers you multiply should be under, like for sure under 10. Like usually they're under like 5. Okay. So you can just start multiplying. You can just start guessing and checking. Like, so if you take the 2.667, whatever, times, calculator's went off, times 2. Okay, that gives us 5.33. Is that close enough to round? No, it's not within a tenth. So that's not going to work. All right, what if we multiply by 3? Well, that's 8.001. That's close enough to round. That's within a tenth. So we would want to multiply by 3. Okay, now, how could you kind of figure that out without guessing and checking? Well, if you look at the decimal portion, 0.667, 0.667 is about 1/3, or I'm sorry, 2/3. Typically the denominator number, you can use that to multiply by and you'll get it. Okay, if you know about what the fraction is. Okay, but like I said, honestly, most people, it's faster if they just guess and check. It's up to you. So I am going to multiply this times 3. Now, if you multiply 1, you must multiply all the numbers of atoms. So I'm multiplying this by 3. I've got to multiply my number down here by 3 as well. Okay, so this, I got 8. That was close enough to round, so I'm going to round that to 8. Down here, 1 times 3 gives me 3. Okay, now I just write my empirical formula. So this is hydrogen, and this was carbon, right? So you could do it in the order I gave you. Carbon almost always comes first, so I'm going to do, so C3H8. That's my answer. Okay, and if you look, I can't divide these by anything and reduce it at all. That's the lowest whole number ratio, which is what I want. So that's my empirical formula. All right. Okay. That's it, guys. So the homework, there's 6 problems. Okay. These are all empirical formula problems. All right. There's nothing special, like, don't get confused by any of the wording. Like there's one on number 6 here that a lot of times people ask about. They give the percentages and then it says by mass. Like the by mass doesn't mean anything. You do it the same way you do any of the others. Okay. If you guys have questions, hop onto the office hour Google or remind text me or whatever. All right. Good luck and I'll talk to you later.